We will be implementing linked list in Python today, and we'll go through various operations on the linked list and the big O complexity. In the end, as usual, we'll have an interesting exercise for you to solve. And here is the list of topics. So if you want to skip ahead to specific topic, feel free. To understand linked list, we first need to look into array because there are some issues with arrays that linked list tries to solve. Here I have an array of stock prices, and this is a memory layout of those stock prices. Basically, there are like 5 elements in this array. If you want to insert an element 284 at location number 1, then it will insert 284 at location number 1 and it will swap all the elements, right? So it will copy 305 from location number 1 to 2, 320 from 2 to 3, and so on. So the array insertion complexity is order of n. Let's try to go a little deeper into detail and see how exactly this works. When you create an empty list in Python, internally in the memory, it will allocate some capacity for that list. Python list is a dynamic array. Now, if you want to know the difference between static and dynamic array, I highly recommend you watch my array tutorial. Here it is allocating a capacity of 5 elements, and when you start inserting elements one by one, it will put those values in. Now at this stage, when you have 3 elements, let's say now you want to insert 284 at location number 1. What happens is, first it will swap those values to make a space for 284. So you can see that there are 2 copy operations. Imagine you have million elements in your array. Now you have to do million swaps. Once it has a space for 284, it will insert. There is another scenario where your array is full of capacity. Let's say I have populated all 5 elements in my list. Now I want to insert 284 at location 1. The way dynamic array work is, in this situation, these are memory locations, by the way, and the one which are grayed out, those are allocated to a different program or some different variable in the same program. So it cannot use this location after 292. Hence, it will go into some different area of memory, which is your RAM, and it will allocate more capacity, and then it will copy all these elements one by one. The way dynamic array works is, if the initial capacity is 5, it will allocate additional 5 into 2, which is equal to 10 memory locations. Then it will copy all these elements here along with 284 value. So here the overhead is not only swapping the elements, but allocating new memory as well as copying all elements from your old memory area to new memory area. So you can see that this is not that efficient. Imagine you have a data structure like this, where the individual values are stored into different areas of memory. Arrays store the value in contiguous memory location, whereas this data structure is storing values at random memory locations, but those are linked by these pointers. So here, my first element has a reference to the address of my next element. So next element 305 stored at location 00A1, and the first element stores the reference. So we are creating like links here, and through these links we can access the next element. In this situation now, when you want to insert 284 at location number 1, it becomes very easy because now you are just modifying the links. So you can see that now I do not have to copy the values from one place to another place. All I did is change the address of this link to C702 because that's the address of 284. Previously it was 00A1. So this insertion operation becomes extremely easy in this new data structure. When you want to insert element at the beginning, the complexity is order of 1. Because all you are doing is creating a new node and then modifying those links. Similarly, if you want to delete the element at the beginning, order of 1. If you want to insert or delete the element at the end or in the middle, the complexity is order of n because you have to iterate through those elements. This data structure is called linked list. It has two main benefits over an array. First, you don't need to pre-allocate the space. You saw in the previous example that I have to allocate a capacity of 5 even before I have populated any element. In linked list, you will allocate whatever is needed. Second biggest benefit is insertion is easier, and we already saw why. If you want to traverse a linked list, you have to go through element one by one, hence the complexity or big O complexity of traversal is order of n. Accessing element by value is also order of n. There is another flavor of linked list called doubly linked list, where you not only have a link to your next element, you have a link to your previous element as well. So here you can see that this particular node 305 has a reference to next element, so 00C5 is the address of the next element, but it has address of previous element as well, which is 00500. This way, if you want to go backward, if you want to do backward traversal, let's say you have 292 and you want to traverse the link in a reverse direction, with doubly linked list it becomes very easy. This chart shows comparison of big O complexity for different operations. The one advantage array has over linked list is if you know the index of your element, in array it's order of 1, which is a constant time operation. Because if you want to access fifth element, you just say your array in bracket 5 and you get that element in a constant time. In case of linked list, if you want to access fifth element, you have to go through first, second, third, fourth, etc. elements, and you have to follow those links. If you want to insert and delete element at the start, in array it is order of n, because remember you have to copy those values. In linked list you don't, hence the complexity is order of 1. Inserting deleting element at the end is order of 1 in array. The reason I am saying amortized is because if you have dynamic array and if you are reaching the capacity, you have to copy those elements. So there is some additional cost. The same operation in linked list is order of n. Inserting element in the middle is order of n in both array and linked list. Now let's implement linked list in Python. I have opened PyCharm and I've created two classes here. The first class is a node class, which represents an individual element in the linked list. It has two class members. One is data. The second one is next, which is a pointer to the next element. Data can contain integers, numbers, or complex objects. The second class is a linked list class where you need a head variable which points to the head of the linked list. First, I'm going to implement a method called insert at beginning. So what this method is doing is it is taking data value and inserting that at the beginning of the linked list. Let's say now you can create a node with value data, and then the next element for that node. So you can see that the second argument in this constructor of node class is a pointer to the next element. Now let's say you already have a head, and if you're inserting anything in front of it, what's gonna happen is you will create a node element, and the next value of that node will be your current head. And once that node is created, you can say that my head now is node. So we will test this method out, but for testing this, we need one utility function called print. So now I'm going to print my linked list. First thing in this function is if, let's say my head is blank, I have a blank linked list, then I want to print that my linked list is empty and return. If it is not blank, then I can just create a temporary variable called itr, which is iterator, and assign head to it. And while itr, okay, itr is equal to itr plus itr is equal to itr dot next. So you are now following the link in your linked list and iterating through element one by one. In each iteration, you want to print a value. So for printing a value, what I'm going to do is I'm going to just create a linked list string. And in that string, I will append that data from that string. And I will just use this character just to show kind of the link between the two elements. And then print that LLSTR. Let's test these two methods out. So first, I'm going to create my linked list and insert some values. So let's say I insert value at the beginning. So I inserted 5, I inserted, let's say 89, and then I'm printing that. So let me remove this extra space, right click, run, edit, and it runs. So you can see that first I inserted 5, and then in front of that I inserted 89, hence it printed 89 and 5. If you want to debug this, you can put a breakpoint and right click debug. That way you get understanding of internally how linked list is working. So my linked list LL is here and my head is pointing to data, which is 89. Then it has a next element, and next element is also of type node, and the value is 5, and the next to that is none. Now I'm going to implement next method, which is inserting at end. In this method, first we need to check if, let's say you're calling this method when the linked list is blank. So your head is blank. In that case, your head would be the node created using that data. And again, remember, in this node, the second argument is next. So since you're inserting the element at the end, the next of that element will be null. And now you're pointing your self.head to that element. So this is very simple logic, and you just return from here. Now let's say your linked list is not blank. In that case, what you want to do is you want to iterate through the linked list and go at the end, and at the end you want to insert this element. So again, I will create an iter, and while iter.next, which means if iter.next has some value, that means I'm not at the end. So then I will keep on iterating. And when my iter.next becomes null, it means I am at the last element. And when I am at the last element, in that element, I will say, okay, the next of the last element was null, and now I want to point it to the new node, which I'm going to create here. So that new node will be node data and none. Let's test this method. So here I created, let's say 5 and 89. Okay, so my linked list is 89 first and then 5. Now I want to insert at the end. What do I want to insert? Let's say some value, 789 or 79. Right click, run. So you can see that 89, 5 and 79. You can also remove these values and just keep on inserting at the end. So let's say I want to insert 79 first, then 1, and then some big value. And when I run this, I will see 79, 1 and 9, 8, 7, 6. So this is working as expected. The next method I want to implement will take a list of values as an input, and it will create a new fresh linked list. Okay, so here in this linked list, first I will say self.head is none, because I'm wiping out all the current values and I am inserting new values. And the way it will look like is, let's say you create a new linked list and then you just call, for example, this method. So I want to insert all these values and it should create a linked list out of that. Okay, so for that I have to iterate through that input list, and I can simply say insert at the end those values, because I have this insert at end function which I can use. Okay, so let's run this function. Voila, so this works. See, it will just create a linked list out of all these values. All right, now I have this function. The next step is to implement a function which can return me a length of the linked list. So I'm just going to copy paste the function. I'm not going to explain you how to write that code because this is pretty simple. All you're doing is you are having a counter and then you're iterating through a linked list and you're counting it. So that gives you the length. Okay, so let me print the length of the linked list. So length of my linked list is ll.getLength, and when you run it, you can see that it's saying 4 because I have 4 elements in my list. Now this getLength function is going to be useful in few other methods that we are going to implement. So now I want to implement a method which can remove an element at a given index. Okay, so for example, I want to call something like this. Okay, and what this should do is it should remove the element at index 2, which is 0, 1, 2. So I want to create this linked list and then remove grapes from that linked list. How do I do that? So you just implement this method saying that remove at this index. So I want to remove the element at this particular index. Okay, so for that, first thing you need to do is you need to validate that index. That index, if it is less than 0 or it is, see, now length, getLength function is being useful. If it is greater than equal to that length, because I'm saying equal to because the index starts at 0, then I will raise the exception saying that this is not a valid index. Okay, after that you can check one more specific condition is, what if you are trying to remove the head? So in that case you will say index is equal to 0, which means remove the element at the beginning of the linked list, which is a head. That scenario is also very simple. In that case, all you do is you say self.head is self.head.next. Okay, so that way you're pointing to the next element and you return. The good thing about Python is it will do garbage collection for you. If you are using C++ type of language, then you have to explicitly clean up the memory associated with your head here. All right, now that we have handled those two special cases, let's start with count, because you are removing the index, and in linked list you have to manually maintain the count to reach that particular index. Okay, so as usual I will do my iter, initialize it to head, and while iter is equal to iter.next. So this is a simple loop which goes through each of the elements in your linked list. Now what we are doing is we are removing the element at a given index. Now just visualize, in linked list you have to stop at the element which is prior to the element that you're trying to remove, and in that element you can modify those links that you have. The link is basically the next link that you have, and that will automatically remove the element. So I need to stop at the previous element, which means when my count is equal to index -1, I need to do something. Okay, here I need to do something. So what do I need to do? So I'm at the previous element. Previous element's next link is pointing to this particular index that I'm trying to remove. Once I remove that element, it will point to next element's next. Okay, I hope you can visualize that. And once you achieve that, you just break out of the loop. So that's it for this method. Now let's test it. Right click, run. Okay, this did not work because I think I did not update this count. Okay, so I need to update the count. And when I run it, I find that grapes, which was at index 2, because 0, 1, 2. So see, the grapes is removed. Now in this particular list, if I say remove at 20, which is of course an invalid index, it should throw an exception, which it did. See, it throw that exception. Also, if you put, let's say, some negative index, etc., again it's gonna throw exception that the index is invalid. Next function I want to implement is insert at, where I provide an index and the value, and it inserts figs, for example, in this case, at the location 0, which is in front of banana. Okay, so I have first check the same check I did in the previous function, which is checking whether index is valid or not. Let's say your index is valid. And another special condition is now you're trying to insert at 0th location. Okay, in that case, you can just say self.insert at beginning. Because we have insert at beginning function, why not make use of it? And you can just return. For all other cases, you need to keep a count. So I'm initializing my counter to be 0. And as usual, iterator initializes it to self.head. And while itr is equal to itr.next. So this is a simple loop going through each of the elements in the linked list. Here again, you want to check whether your count is index -1. Because when you are inserting the element in the linked list, you want to modify the next pointer of the previous element. That's why we are stopping at the previous element. See, index -1. That's why we are doing that. Once you are here, and by the way, if we need to write some code here, but before I forget, because I did last time, I want to increment my count. Okay, all right, now what do we want to do here? Let's say you are at the element prior to the element that you want to insert at. In this situation, you can first create a node. Okay, so your node is basically the node containing data, and the second argument in node class is the next element, next pointer. So the next pointer here will be itr.next, because you are at the previous element, and previous elements next will be your this element's next, because you are kind of sneaking in between. And then itr's next will be node. Okay, and once you do that, you can just break the loop. Let's run this code. So here you can see that figs I tried to insert at the beginning, and it did insert. So this was my original list. Now in the beginning I have figs. Let's try to call this method one more time, and let's say now at this location, so let's say 0, 1, 2. Okay, before mango, I want to insert jackfruit. All right, I love jackfruit. 1, 2. So you see my original list. Okay, let me print list after this, so you kind of get an idea. So before inserting jackfruit, my list was like this. Now at the index 2, which is at the mango, I inserted jackfruit. So you can see the jackfruit came in place of mango and mango was pushed down by one position. In the linked list, you can insert string values, integer values, even complex objects. So let me just quickly demo you the integer values, like how does it look like. So if I have something like this where I'm inserting a couple of values and then I'm saying insert at the end. So if I do run, see, I had up till 99 and then it inserted 67. I can test few other methods as well, which is, let's say I want to remove, let's say 12. So the location of 12 is 0, 1, 2. So 2 ll.print, run it, and it removed 2. The code that I showed you is available on my GitHub location. This is the location. I'm gonna provide a link in the video description. So please check the video description for the code that I used in this tutorial. Also, I have a very interesting exercise for you. Exercise is, as usual, the most interesting part of any tutorial. If you just watch the tutorial, you're not going to learn anything. It's like swimming. I give this swimming example all the time. Unless you practice coding, you are not going to learn it. So forget it. If you don't want to do exercise, you're wasting your time. So for this exercise, I have two problems that I want you to solve. The first one is implement these two additional methods in the linked list class that I already have. So you can take this particular class, okay, copy the whole thing and add these two methods. And these two methods are inserting and removing the elements by values. In our original code, we did it by index. Now you are removing it and adding it after value. And it should support all of these calls. There is a solution link here, but if you click on solution link before trying on your own, then what will happen is I have a magic. You are going to get a virus in your computer. Okay. So do not look at the solution directly. Try to implement yourself first and then look at the solution. The second exercise is to implement doubly linked list. In doubly linked list, the only difference is you have a link to previous element as well. So your node class will look something like this. And you want to implement two functions, which is print forward, print backward. And all other remaining methods that we had, you have to update those methods to account for your node.previous element. Again, there is a solution link here, but look at the solution only after you have tried it yourself. That's all I had for this tutorial. I hope you're having an amazing time. If you like this video, please give it a thumbs up, because those thumbs up helps in YouTube ranking and other people can also benefit from this tutorial. Okay. In the next tutorial, we are going to look into hash table. Thank you.